Hello everyone, welcome to 8th session on numerical analysis of BSc 5th semester. In this session we shall discuss about the numerical method of solving the nonlinear algebraic and transcendental equations. In the previous session we have discussed about the computation of errors in the function f of x1, x2, xn. We have solved a couple of examples related to that topic. Now in this session we shall discuss what are meant by the nonlinear equations, what are the transcendental equations, and what are the different numerical techniques for solving such equations, that is nonlinear algebraic equations and the transcendental equations, that we shall discuss in detail in this session. Now first of all, let us try to know what are the linear equations and nonlinear equations. First, let me tell you what are the equations. Equations are the relations between known quantities and the unknown quantities, with the help of which we can get the value of the unknown quantity in terms of the known quantity. That we say it as an equation. If in the equation the unknown is appearing in the first degree, then that equation is called as a linear equation. On the other hand, if the unknown of the equation appears in the degree more than 1, then such equations are called as nonlinear equations. So, for example, if the unknown is denoted as x, if we write x plus 5 equal to 0, then it is an equation. Here unknown x is appearing in the first degree, therefore the equation is a linear equation. That is an equation of the form ax plus b equal to 0, where a and b are the coefficients and x is the unknown. That equation is called as the linear equation. On the other hand, if the equation contains the unknown variables in higher degree, that is degree more than 1, such equations are called as the nonlinear equations. So, for example, the equation x square plus 2x plus 1 equal to 0, that is the first equation. Here you can observe the unknown here in this equation is x, and x is appearing in degree 2. So degree of the unknown in this equation is more than 1. Therefore this entire equation we call it as a nonlinear equation. Similarly, the equation x cube minus 1 equal to 0, unknown is x and it is appearing in degree 3. Therefore this is also a nonlinear algebraic equation. Now you look at equation 3, that is the third equation here, x plus sine x equal to 0, and another equation, that is e to the power of x minus 2x equal to 5. These two equations are also the nonlinear equations. You can ask me a question that here x is not appearing in degree 2, then how can these equations be nonlinear? In the previous two equations, the unknown x was appearing in degree 2 and here it was in degree 3. Therefore, these two equations were nonlinear. We agree with the definition. But in these two equations, unknown is again x, but x where x is appearing in degree more than 1. That is an important thing to be noted. Now if we look at in these two equations the terms sine x, in the first equation you look at the term sine x is non-linear term in x, because sin x, when you expand it using the Maclaurin series, that is Taylor series in the neighborhood of 0, then the sin x term, the sin x expansion will be like x minus x cube by 3 factorial plus x to the power of 5 by 5 factorial minus x to the power of 7 by 7 factorial. So this term is going to give us the non-linear terms in x after expansion. So we can say that trigonometric function is always a non-linear function in its argument. Argument here is x. Therefore, such terms make the equation non-linear. Similarly, in this equation, e to the power x, when you expand it using the Taylor series, it is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x to the power of 4 by 4 factorial plus dot dot dot, like that. So this is also giving us the higher degree terms in x. Therefore, this term is also making the equation non-linear. So therefore, such equations are also called as non-linear equations. However, a special name has been given to these equations, and that name is the transcendental equations. We say that such equations as the non-linear transcendental equations. Transcendental equations are those which contain non-algebraic terms. So the algebraic terms are x, x square, x cube, like that, x plus 1 or x plus 1 whole square, x minus 1. Such type of terms are algebraic terms. The non-algebraic terms are like trigonometric terms, logarithmic term and exponential term, hyperbolic terms. Such terms, if they are present in the equation, then we call such equation as the transcendental equation, and definitely they are the non-linear transcendental equations. So I hope you understood very well what are the non-linear equations and what are the non-linear algebraic equations and non-linear transcendental equations. Now let us go for the next topic, next concept, that is what is meant by the solution of the non-linear equations. In general, solution of any equation means the value of the unknown, which when substituted in the equation must be balanced. That is, LHS should become RHS. That type of relation is called as, that type of expression, the expression which is a relation between known quantities and unknown quantities, which when substituted in the equation must be satisfied. So such an expression is called as the solution of the equation. Here we are going to get the value of the unknown. That is very important. We are going to obtain the value of the unknown, and that we call it by a particular name, that is root of the equation. So root of the equation is the value of the unknown for which the equation is satisfied identically. This process is very easy when the equation is of first degree. For example, if x plus 5 equal to 0 is an equation, then we can immediately say that x is equal to minus 5 is the solution or root of that equation. But the process of solving the equation, that is obtaining the root of the equation, becomes tedious, becomes difficult, as the degree of the equation, degree of the unknown which appears in the equation becomes more and more. That is, higher degree equations are very difficult to solve as compared to the lower degree equations. In such cases where the analytical methods are those which are giving us the solution in a closed form, and in most of the cases in the exact solution. So such methods are called as the analytical methods. For example, if we have a quadratic equation, factorization is one of the methods of solving the equation. That is an analytical method. If factorization is not possible, formula method is there. That is using the formula minus b plus or minus square root of b square minus 4ac divided by 2a. That is also an analytical method. And even for cubic equation we have analytical method. For biquadratic equation also we have analytical method. But the analytical methods will be very difficult as the degree of the equation increases. Or even we can say that for higher degree equations there exist no analytical methods. So in such cases where it is difficult or impossible to solve an equation analytically, this is very important. If it is difficult to solve or if it is impossible to solve analytically, then we prefer the methods which are called as the numerical methods. So what are the numerical methods? Numerical methods are the methods which are giving us the approximate solutions. So therefore these methods are the approximate methods. Analytical methods are the approximate methods, and these methods involve the repeated application of the same process, and therefore we call these methods as the iterative type of methods. What is going to happen in the numerical methods? In the numerical method, we start the process of solution with some initial approximation, and we use some predefined formula of that particular method, and we substitute the value of the initial approximation in the formula and get the first approximation. Then we will not stop at that moment. We go on applying the same formula repeatedly by using the value of the unknown which we obtain in the previous iteration or the previous step. For example, if we start with the initial approximation and obtain the first approximate solution, then we will go for the second step, that is the second approximation, by substituting the value which we obtain in the previous step, that is first approximated value. Likewise, and then we get the second approximated value. And we see the difference between first approximated value and second approximated value. If it is more, then we will not stop. Again we proceed. We proceed for the third approximation, where we are going to use the second approximated value in the formula. And we obtain the third approximated value. And in the same way we go on proceeding by substituting the previously approximated value in the formula, and we go on getting more and more a better value of the solution. Such type of method is called as iterative type of method or iteration method. And these methods will always give us the numerical methods are the iterative type of methods, and these methods will always give us the approximate real root of the equation. So these are going to give us, very important to be noted here, these are going to give us approximate real value of the solution. Numerical methods will not give us the exact solution, they give us the approximate solution and the real solution. The value will be a real number. So therefore we in this method are intended to find such solution which are approximate and which are real. So in this way we go on applying the iteration method and go on improving the value of the unknown, and we stop the process when the difference between two consecutive values of the unknowns. For example, if we are at the ith iteration and we get the ith approximated value, we see the ith approximated value, and what about the I minus 1th approximated value? That is the approximations obtained in two consecutive approximations, two consecutive iterations. We will see if the difference is very small, That is, if they are almost same, then we stop at that process, at that particular stage, and we say that the value obtained at the ith iteration is the required value of the unknown. So this is about the iterative type of method. I hope you understood very well the concept of numerical methods of solution of the equations. As far as the nonlinear equations are concerned, the numerical methods for solving the nonlinear equations are many. Out of them, for our syllabus, 4 methods have been prescribed, and these methods are: the first one, bisection method; second method, method of false position, or it is also called as regula falsi method; the third one is Newton-Raphson method, and the fourth one is secant method. So these are the 4 methods which we will be discussing in the next sessions one by one in a very detailed manner, and at the same time we are going to solve a couple of examples on each of these methods, and therefore this topic is going to be very interesting topic, and I hope you understood very well the basic concepts related with the numerical method of solving the equations. With this, let me stop for this particular session and try to answer to these multiple choice questions. This is the first question, this is the second question, this is the third question, this is fourth one, and this is fifth one. Please have a reference of the book, once again Numerical Analysis, which is having the title as UG Mathematics 5C, written by me. Please refer this book and try to get further information. With this, let me stop. Thank you.